Welcome back, Math 7. Today we are continuing our probability lesson on Chapter 9, which I just realized this is Unit 9, Probability. As you may know, we are going back to online form of learning because of COVID announcement and new regulation. Today we are going to learn how can we organize entire total outcome. And we are going to use one of the method today, which first lesson, we're going to learn how to use table. And when it comes to second lesson, which is tomorrow, we're going to learn about how we can use tree diagram. Organizing outcomes, you need to know about two terminology, folks. One is every single type of outcome is happening because of independent event. What I mean by that is one of the event will have zero effect on the outcome of another event. For example, imagine if you have a coin. Coin has two possibilities, head or tail. When it comes to, let's say, spinner with four sides that has A, B, C, D. And then imagine you have a spinner with the arrow over here. As you may notice, the total possibility of this spinner is A, outcome, B, C, D. Independent event is talking about that if I have one event, in this case coin, and the other event, which is spinner, the event that is happening between coin and spinner is independent. There is no bias trend happening in that situation. So just because coin has tail, that doesn't mean it's preferring vowel, for example. Whatever that head or tail outcome is not affecting the other outcome. That's what you can think of. And sample space. This is every single, all possible outcome of an experiment. So, like I mentioned, to find a sample space, there is two different ways. One way is known as table. The other one, tree diagram. That's something that you need to understand. And if you flip a coin twice, you can model the possible outcome using a tree diagram or an outcome table. And that's an example that you see on the left side and right side. Like I said, part 1 will talk mainly about the table construction, and part 2 lesson will be mainly focusing on tree diagram. Without further ado, let's look at a class example. This is available on workbook page 7, as you can see. So let's look at the scenario. A coin is flipped and a 6-sided die is rolled. These two events are called independent event. Gonna highlight a coin, which is event number 1, and a 6-sided die, which is event number 2. And we are imagining throwing these two up in the air, something like that. We are going to use a table to determine the all possible outcome, and B, how many possible outcomes are possible to have, and C, write a sample space, which is a total number of outcome for the combination of event number 1 and event number 2. That's what you can do. Table. Whenever we construct table, ladies and gentlemen, it's a good idea to have horizontal area so that I can have each of the column and row vertically so that I can find out what event is what. As you may notice, I'm dividing the first space by half by putting a diagonal line, because first event I'm gonna put coin possibility, and second event I'm gonna put six-sided die on the horizontal. So in this way, you can only focus on one event at a time. When it comes to coin, it's easy. You have two possibilities, head and tail. H for the head, T for the tail. Like that. And when it comes to six-sided die, how many possibilities that we have? Well, like the word suggests, it's six-sided. So 1, 2, 3, 4, 5, and 6. Something like that. So, like what I mentioned, you need to decide whenever you need to create a table. It doesn't matter. You can put six-sided vertical and coin horizontal. But in any case, one of the event will decide a column. One of the event will decide row. Something like that. And after that, we are combining every single thing. There is one possibility where you can have head and 1. Or tail and 1. Same thing, I want you to put all of the possibility and fill the empty part over here, which is components of the table. And know the fact that it has to be using bracket system to give you a consistency. And by doing that, ladies and gentlemen, we answer the first part. Use a table to list all of the possibility, all of the possible outcome. So what I'm highlighting over here, which is inside component of your table, ladies and gentlemen. From now on, we're gonna call every single component inside of the table. When you have more than one event going on, these are what we're going to say as sample space. It literally shows every single possibility, which we're talking about. Now we can go to the B section. How many possible outcomes? You literally count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outcomes you have. And since you have all 12 outcomes, now when we describe entire sample spaces, we can list everything, even though a table part already found it, but sample space, head 1 is 1, head 2, head 3. You got the idea. Oops, sorry. There's no 7. Tail 1, tail 2, tail 3. This is the only tedious part. This is all the sample space for this combination and event, and make sure that coin event does not affect the outcome of six-sided die. This is a little bit of assumption that we have. In sample space, when we create or find out all possibility, one event is independent to another and vice versa. That is one of the example, folks. Let's do one more. Why don't we do, let's see, yeah, page 8 example. Page 8. A toonie is flipped, which is one of the material, and a four-sided die is also thrown, labeled 1, 2, 3, and 4, which is what you see over here. We are going to list all of the possible outcomes and how many possible outcomes are there, and we're going to write down the sample space for this combination of event. Let's create a table. This time, why don't I create a table where I have coin on horizontal location over here, which is head for one column, tail for another column, something like that. And when it comes to the other part of the graph, in this case vertical, why don't I put a four-sided die? And each outcome, I'm gonna put those accordingly. Generally, we put row first and then column later. So the first outcome is combination of having one from the die and then H from the toonie, one and tail, two head, two tail, three head, three tail, four head, four tail. So long story short, we have all of the possible combination inside here. And I'm gonna put all possible outcomes. So the A part, ladies and gentlemen, it's done. B. How many possible outcomes are there? Well, why don't we count it? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 total possible outcomes here. There are, if you actually put everything, you should better start with, there are 8 total possible outcomes. C. Write the sample space. Then we gotta write every single thing, and I know this part is tedious, so in my actual test, when you create table and or tree diagram, one of them will be good enough because I can actually see the sample space, but this time it's a practice anyway, so sample space for this combination is 1 head, 1 tail, 2 head, 2 tail, 3 head, 3 tail, 4 head, 4 tail. So we have all of those 8 sample space available. That is today's lesson. Shortly after, I'm going to put many questions to reinforce this skill. And even though in the textbook it may say give it a shot using tree diagram, try to use table anyway because that's today's focus. That is today's lesson.